Today I'm going to show you how easy to create a box joint using NC Sender. So let's start by installing the plugins that I created. So let's go to the settings, install plugin. You'll see there's a new box joints plugin. So click install, done, close. And then you will see another tool here, a box joint. So in here, already have a UI for the parameters that we need to set up. But before that, let's actually set up, let's me remove one of my wasteboard so I can do a vertical cut. To speed up is, if we go to the UI, there's an options to generate pins and tails. For faster and to reduce the setting up of the origin, we're gonna cut at the same time both pins and tails. So there's a third option on the piece type, both. And then if you read the instruction, it says we need to place the two board piece, which is this one. But before I put this, I'm gonna measure it first. Let me just grab my caliper. So let's put this number parameters on the input fields. So the board width is, let me make sure that this is correct. So the board width is 87.65 millimeter. So I'm gonna type it here. 87 point, let me do that again. 87.77. And our board thickness is 18.82. So 18.82. And then we can visually we can see the number of pins, so we can increase it. You can keep increasing it, and then to the point that it will tell you that the bits that we're gonna use won't fit on the slot. So let's reduce it down. So let's do a 7, like look nice. And then, like I said, we're gonna generate both pieces, A and B, and then I'm gonna do depth per pass. I'm gonna do 7, and then for the for the tools, for the bit I'm gonna use, I'm using a compression bit, which is a 1/4 inch, so 6.34 millimeter, and RPM is 18,000. Then I also want to do a plot. Actually, no, we're just gonna do. And then from here on the calculated dimension, it will tell you that our finger width will be 6.7 millimeter, which is still fits more than the bit diameter that we're gonna using, and the slot is 6.8. Actually, let me do the tolerance, because last time I tested, the 0.1 is too tight. So let me do maybe 0.4. So now it will change. Our slot now is 0.7 millimeter. Our finger width is 6.6, which still fit on our bit. So let's do generate. I'll zoom it. Now auto fit here. So it looks like, based on the G code generated, it looks like it's twice the width of our board. So now let's mount it. That should be good enough. Let me tighten this. Okay. So according to the instruction, if we go back to the plugins, we need to set our 0, on front left. So this will be our corner of the origin. So I'm gonna use my 3D probe. Okay, and then continue. Okay, then we'll move this to our 0 0, supposed to be 0 0. Okay, now we're gonna probe this our work offset 0, so we're gonna go to probe, and then I'm using my touch probe, which is gonna do XYZ, and let me change the diameter 1.8. Z offset, that's negative 0.1. Okay, let's trigger it to enable and start the probing. Okay, we have our work offset 0 0 on G54. Now let's load the tool that we're gonna use. I'm using my T6, tool 6. Okay, it says I need to unload. And then click continue. Okay, I think we're ready to cut. Let me just wear some noise protection. So I'm gonna click start. Okay, it's done. Let's move away. It seems like I didn't put the board straight, so there might be a fitting issue, but we'll see. Look at this, like there's a gap on the bottom. This is a test anyway, so I don't need to really. But if it's a real one, I probably have a much better clamping. So let's see. There you go. So I use 0.4. It's a little bit loose, but I think that's good enough for gluing. Let me actually do quick cleaning. Let's see. So where's my sander? Here. Very nice. Just need to glue up and looks good. Maybe I just put glue on it. There you go.